following transportation problem. Solve the following transportation problem using Vogel's approximation method with the demands and supplies as given in the question. Okay, let us now try to solve this problem. The problem is of 3 cross 4 problem. So you have 3 rows and we have 4 columns. 3 rows and 4 columns. The columns are corresponding to the sources and so named as S1, S2 and S3. The destination named as B1, B2, D3 and D4. By the side of it we have the supply. By the base we have demand. Making entries appropriately in the cost Cij in the cells. We have 6, 11, we have 10, then 1, 5, 12, 1, 5, 12, then we have 9, 2, 4, then we have 3, 8 and 7. The corresponding supplies are 70, then we have 55, then we have 70. The corresponding demands are 85, then we have 35, then we have 15, then we have 45. So totally here it is 140 plus 50 is 195. So here it is again 5, carry over 1, 5 plus 5, 10, and then 10 plus 11 is 10. Now look at this. Here it is 195 and here it is 210. Therefore, here it is going to be 210 over this side. Therefore, it is not valid. Hence, our sigma Ai is not equal to sigma Bj. Therefore, it is an unbalanced transportation problem. Therefore, it is an unbalanced transportation problem. So the first step here is we convert this into a balanced transportation problem. So how do we convert this into a balanced transportation problem? Look at it. Our Bj is less than Ai. So our Bj minus Ai, my sigma Bj minus my sigma Ai will be negative in this case, isn't it? My sigma Ai minus my sigma Bj, this value will become 210 minus 195, giving me the number 15. So what we do is we convert this into a balanced transportation problem having the cost as given and supply is equal to demand by adding a dummy row. So now when we add a dummy row to this problem, what do we get? The given problem gets transformed into, the given problem will now get transformed into, we will have 4 rows and we are going to have 4 columns. So these are the 4 rows as given. The last column is last row is a dummy row. So the entries will be 6, 11, 10, 0. Then it will be 1, 5, 12, 1, 5, 12, 9, 2, 4, 9, 2, 4, and then it is 3, 8, 7, 3, 8, 7, and the dummy row entries are all zeros. Now we enter the supply and the demand, apply Vogel's method. So we have 85, we have 35, we have 50, and we have to check what we need at the base over here. 85, 35, 50, and then we have a 45. We need to get the tally over here as 2 and 5. So given entries under supply we have 70, we have 55, again we have a 70, so it amounts to 195. So here we will add an addition of 20. Now the problem is a balanced transportation problem. We apply Vogel's approximation method in order to obtain the initial transportation cost. So how to apply Vogel's approximation method? We subtract the smallest from the next to smallest in every row and every column in in order to obtain the penalties. So here it is going to be 6 for us. Here the value is going to be 1. Here the value is 2. Here the penalty value is 3. Here when we combine the side, 3 minus 1 penalty is 2. Then here 5 minus 2 penalty is 3. And 7 minus 4 penalty is 3. Again 0 minus 0 penalty is 0. The highest penalty is 6. So we can choose the first column. In the first column we have to choose minimum of 80 and 75. So let us check what happens when we proceed with it. What do we get, whether 80 or 75? Start allocating. By allocating costs to the topmost cell, we now need to check how much could be allocated to each of these cells. In general, without these allocations, if we leave the dummy row and then if we apply Vogel's approximation method, now check what happens to the solution. Okay, either way you can do. So now you have to choose a minimum of 85 and a minimum of 70. See what happens. Whether you are able to get 80 and 75, or the next is what we can do is we can choose the smallest and the next smallest value. We need not consider this dummy row. Without considering the dummy row, if we give the allocations, check what the solution is going to be like. Okay, so check what happens. That time the allocations here could be all different. So here you will have 10 minus 11 value will be 1. Here you will have 5 minus 1 value will be 4. And here you may have 4 minus 2 value will be 2. And here you may have 3 minus 7, the value will be 4. And by the side we can have the value will be 3 here, the value would be 3 here, again the value would be 3 and 0. So either way, considering our allocations, so now we have got the highest penalty to be 6, it has to be allocated to the least cost cell that is available. So the least cost cell is 0, so you can either allocate 85 or 20. Let me allocate a 20 to this cell. So this gets blocked. Here the value still remains to be 3, 3 and the value is 2. Then come down. We have to go for the second penalty count over here. Here we need not have any penalty count because 85 only 20 is satisfied. So we need to check the smallest and the next smallest. So how do you go about the smallest and the next smallest? This row gets cut now. Calculate the values. Calculating penalties, we have 6 and 11. The value becomes 5. Here it becomes 5 minus 1. Penalty becomes 4. Here it is 4 minus 2. The penalty becomes 2. And here it is 7 minus 3. The penalty becomes 4. Now choosing the maximum. Maximum is again 5. For this 5, minimum value in the grid is 6. For 6, either you can allocate 85 minus 20 is 65 or 70. So minimum of 65 and 70 is 65. So allocate 65. Once you allocate 65, this column gets cut. Okay. So now start the procedure as usual. So this column is also out for us. Now here 5 minus 1 value is going to be 4. Here the value is going to be 2. Here the value is going to be again 4. Coming by the side, here we have the value to be 2 and then 5 minus this value to be 3 and then the penalty over here is also 3 and this we don't have to calculate. So the highest penalty once again is 4. You can either choose the first 4 or the second 4. Let me choose the first 4. If I have to choose the first 4, the least cost cell cost is 1. So I can either allocate a 35 or I can allocate of the 70, 65 is given, so I can allocate only 5. Since I have allocated 5, now 65 plus 5 is 70. So the first row is over. So the supply is gone. So we strike the first row. Now proceeding in the usual manner, wanted. We have 8 minus 2, value is 6. 4 minus 7, value is 3. So we choose 6, which is the maximum. Go for the least cost, that is 2. Already 30 is given. I can give only 25. So give the 25 so that this particular supply gets satisfied. So even this gets struck. So you have 30, 25 satisfying 55. Now what else is remaining? What else is remaining is only this position. This position is again 25. 25 plus 25 is 50. Now out of 70, 25 is gone. Remaining 45. The remaining 45 could be allocated over here. Now if you look for the tally, you may find that the fourth column is also satisfied and the third column is also satisfied, and hence we have reached our optimum allocations. So this is our allocation that we have got. Once we have got this allocation, look at the number of allocations. We need to check number of allocations. Number of allocations, what is the value? My number of allocations equal to how many allocations? First row 2, second row 2, third row is also 2, 6 plus 1, 7. And what is m plus n minus 1? Number of rows is 1, 2, 3, 4. 4 plus 4 is 8. 8 minus 1, value equal to 7. Now since m plus n minus 1 is equal to this, that is a non-degenerate solution has been achieved. Non-degenerate initial BFS is obtained. Non-degenerate initial basic feasible solution has been got for us. Next, what we need to do is we need to check for the optimality of this solution. So how do we check for optimality? So let us redraw the table for convenience. Step 2, we have to check optimality. We are going to check the optimality using what method? Modi method. We are checking optimality using Modi method. So now let us redraw our table for convenience. We had a 4 cross 4 table. So we have 4 rows and we have 4 columns. Let us make the appropriate cell entries and their allocations. We had a dummy row. So we have 6, 11, 10, 0. We have 6, 11, 10 and 0. 1, 5, 1, 5, 12 and 0. Then we have 9, 2, 4 and 0. And we have 3, 8, 3, 8, 7 and 0. So where did we have our allocations? We had a 65 on the top. We had a 5 over here. And below this 5 we had a 30 allocated in the second row, second cell. Next to the 30 we had a 25 units allocated second row, third cell. And then below that again there was an allocation of 25. And next to this 25 we had an allocation of 45. Then the last row for the dummy variable, first dummy cost, we had an allocation of 20. So now 20 plus 65 is 85, 30 plus 5 is 35, 25 plus 25 is 50, and then 45. Yes, all our demands satisfied. 65 plus 5 is 70, 30 plus 25 is 55, 25 plus 45 is 70, and the last row is 20, and hence all our supplies are also satisfied. Now we need to apply Modi method. So what we have to find out is we need to find out all our Cij. Cij is equal to Ui plus Vj. So let us now calculate Cij equal to Ui plus Vj. For what cells should we do this? Think once. For what cells should we do this? Either occupied cells or unoccupied cells? Yes, please. Then calculate all yourCijs. After calculating all theCijs, what we need to do is we have to check whether theCijs, using this we calculate Dijs and check whether our Dijs are all greater than or equal to 0. So we first need to findCijs. Cij equal to ui plus vj for the what cell? Allotted, allocated cells. So I need to find my C11. My C11 equal to U1 plus V1. What is my C11? C11 value is 6. So I have 6 is equal to U1 plus V1. Then I have 1. 1 is equal to U1 plus V2. For convenience, we may note U1, U2, U3, U4 by the side and the top of the table so that it is easy for us to write. Okay. So our entries are 6 is U1 plus V1, 1 is U1 plus V2, then 5 is U2 plus V2, 2 is U2 plus V3, then 4 will be U3 plus V3, then I will have 7, 7 will be U3 plus V4, and then I will have 0 equal to U4 plus V1. 0 is equal to, I'm going to have U4 plus V1. Now check for the row or the column which has maximum allocations. We find 3 rows are having all allocations 2 to 2. Similarly, 2 columns have maximum allocations 2 to 2. So it is our choice to put anything as 0. So I suppose we can take either we take V1 is 0 or we can take U2 is 0 or U1 is 0. So let me take my U1 to be 0. If I take my U1 to be 0, I get my V1 equal to 6. Then I get my V2 equal to 1. Then what else I have? My V1 is 6, U4 is minus 6. I will have U4 value to be minus 6. I have V2 is 1, U2 will be 4. So U2 will be 4. Then if U2 is 4, my V3 will be minus 2. So I will have my V3 value, V3 will be minus 2. If V3 is minus 2, U3 will become 6. So I will have U3 to be 6. Now V4 will become 7 minus U3 or 7 minus 6. So I will have my V4 to be 1. Now let us check U4 value alone once again. My U4 is minus V1. V1 is 6. So U4 is negative 6. Now what we have to do? That is our step 3. What to do in step 3? I have to calculate all my Dij equal to Cij minus Ui plus Vj. For what should I calculate? For unoccupied cells. I should calculate this for unoccupied cells. So now let us calculate this. We need to find for D13. So what is our D13? C13 9 minus U1 plus V3. U1 is 0, V3 is minus 2. So value is 9 plus 2 equal to 11. Then I calculate D14. My D14 value is 3. So 3 minus U1 and V4. So it is 3 minus 2. 3 minus 1 value is 2. Then I calculate for D21. My D21 is 11 minus U2 plus V1. V1 is 6, U2 is 4. 11 minus 10 value is 1. After our D21, I have to calculate D24. What is D24 for me? D24 is 8 minus U2 V4. 4 plus 1 is 5. Value is going to be 3. Then I have to calculate D31. What is D31? D31 is going to be 10 minus U3 V1. U3 is 6 and V1 is 6. See, 10 minus this is minus 2. So this has to be noted and taken care of. D31 is now negative. Now come for our D42. I will write by the side the other values also. We have to calculate D42. What will be our D42? It is going to be 0 minus U4 V1. U4 is minus 6. V1 is plus 6. So value becomes 0. Then I have D For my B43, it is 0 minus U4 and B3. So it is 8. Then I have to calculate my D44. D44 is 0 minus U4 and B4 value is 5. So the only problematic position is where my D31 becomes negative. If it is equal to 0, it is fine. It only depicts that there is going to exist an alternate solution. Right. So alternate solution we need not bother right now. We have to check into this negativity. Now where does this negativity occur? D31. So I am representing it by an asterisk symbol. So this is the point where the negativity occurs. So we need to remove this negativity by forming a loop. So how are we going to remove the negativity? That is our next constraint. So what we'll do is we have to draw a loop in such a manner using only horizontal and vertical lines to cover all these cells with this star. Now, if I am to draw one such loop, let me take maybe a different color. Please look, I will go from 65 to 5. From 5, I come down to 30. From 30, I go to this particular cell. Again, I come down. Again, if I go here, it will not help me. So, I should not travel to this extreme. Okay? I should not travel to this extreme. Let me put this up. So, here I had a 45. Here I had a 45. So what I will do is, I will come down to this 25, come straight down. With this, I will reach the position where I am having the negative value. And then, now what happens? We are supposed to assign a very huge cost to the position where we have the negativity. So from the three cells, what are the three cells? 1, 1, 1, 2, and 2, 2, and 3, 3. 1, 1, 2, 2, and 3, 3. Now look at all these cells that we have got here. What is the minimum value? The minimum value that we have here is your cost is 65, and then after 65 you have 5, 30, then you have 25, 25, and so on. So which is the minimum? The minimum is 25. So how do I allocate this value? We will see it in the next slide. Okay. How to allocate this particular value? Now let us consider our table once again. Let me make my table a bit bigger. We are going to have 4 rows and we are going to have 4 columns. Right. So what were the allocations that we had? We will note down once again. We had 6, 1, 9, 3. I have 6, 1, 9, 3. Then I have 11, 5 to 8. I have 11, 5, 2, and 8. And then I have 10, 12. I have 4. I have a 7. And then I have a dummy row comprising of all zeros. Now I had my allocations. I had a 65 on top. I had a 5 on here. And then I had a 30. Then I had a 25. Again below that I had another 25. And below the 5 I had a 30, 25, 25. And then I had an allocation of 45. And then I have a 25. And then my asterisk point where I had most negative. The place where I have most negative, I will add a huge value which is plus theta. Okay, which is plus theta. So let us add a plus theta at this position. So where was my loop? My looping went like this. It came to this 5. It came to this 30. It came to this 25. And then finally my loop closed here. Now what were my allocations? My allocations were 65, 5, 25, 25, 20, and then theta. So now what I have to choose is the two cells which are very much adjacent to this positive theta. If it is positive theta here, what we actually need to do is assign alternatively positive, negative. So in this position, if it is positive, here I should have a negative beta. Here I should have a positive beta. Here I will have negative beta. Here I will have positive beta, and here they will have negative beta. So in the alternate locations, I am having positive, negative, positive, negative, positive, negative. Okay. Now what we have to do is what we should take for the theta. So now let us take for theta. Our theta will be minimum of the values that are there in the grid so that nothing becomes negative. So the minimum of the negative value is either 65, 30 and 25. So minimum of 65, 30 and 25, and this value is nothing but 25, right? So now what we will do is we will add these appropriate values to the table. So from here we move on to this particular table. Once again I redraw so that you don't get confused. So we are going to have 4 rows. We are going to have our 4 columns. In these 4 columns we are going to have our allocation 6, 1, 9, 3, second row is 11, 5, and then I'm going to have a 2, and then an 8, then I have 10, I will have 12, I will have 4 and 7, and then all zeros. Now what we need to do? We have to add or subtract depending upon minus theta or plus theta. Theta value is 25. So here we have a plus theta, so we add a 25. What we add here, we subtract on the top. So 60 minus 25, 65 minus 25 value is 40. What we subtract, we add with the 5 in this position. So it is 5 plus 25. In this position, it becomes 30. Now, what I have added, I have to subtract with this 30 in this location. So, 30 minus 25, I will have a 5. Then, what I have subtracted, I should add here. Here I will have 25 plus 25, value becomes 50. So what I have added, I should subtract here. So here the value becomes 0 and this 45 remains as such undisturbed. Now look at the number of allocations. Look at the number of allocations. How many allocations are we having? Yes, how many allocations are we having? We have to check the number of allocations that we have. So how many allocations are we having? Yes, we have a 40, we have a 30, we have 5, 50, 25, 45. And then in the last position, I left out the allocation we had here was 20. So that 20 also remains undisturbed. So number of allocation is 1, 2, 3, 4, 5, 6 and 7. Our m plus n minus 1 equal to 7 equal to number of allocations. Now again we have to calculate our Cij and Bij. Now this 0 is not treated as an allocation because cost is 0. It is the same as writing there is no such allocation. So number of allocations is now 7 and so we need to calculate our Cij and Dij for this table. So how to calculate the Cij and Dij? Once again calculate it for all occupied cells and for all unoccupied cells. So now we start calculating our Cijs for all occupied cells. So when I calculate my Cij for all occupied cells, I have to redraw the table once again. So next, we calculate Cij for occupied cells. Okay. So what are the occupied cells? If we refer back to the other previous table over here, we have our cells as C11 and C12. What is our C11? C11 is 6. So 6 is equal to U1 plus V1. Then I have next 1 equal to u1 plus v2, that is c12. I have my c12. My c12 equal to u1 plus v2. So c12 value is 1. Then I have c22. C22 value is 5. That is equal to u2 plus v2. Then I have c23. C23 value is 2. 2 is equal to u2 plus v3. Then we have c31. C31 is 10. u3 plus v1. Then we have c34. C34 is 7. 7 is u3 plus our v4. Then we have c41 value is 0. So it is u4 plus v1. Now look for the maximum allocations which we can find in a particular column or a row. We can check v1. v1 is occurring 3 times. So we put v1 equal to 0. You will get u1 equal to 6 and you will get u3 equal to 10 and you will also get your u4 value. My u4 value is minus v1, so u4 value is equal to 0. Now with these values, let us find v2. v2 is 1 minus u1, so v2 is minus 5. Let us find v3. v3 is 2 minus u2. What is my u2 now? My u2 is 5 minus v2. 5 minus v2 means minus of minus 5, so plus 5, so u2 is 10. If u2 is 10, my v3, what happens to my v3? u2 is 10, so v3 is minus 8. I need to get my v4. v4 is 7 minus u3, v4 value is minus 3. Once I have calculated all my ui's and vj's, the next thing what we normally do is we calculate dij, correct? We calculate dij. What is this dij? My dij is nothing but our cij minus ui plus vj. For what should I do this? For unoccupied cells. I should do this for unoccupied cells. Now come here. What are your unoccupied cells? Next is I have to look for that. I have D13. Am I correct? Yeah. D13. D13 is unoccupied. So D13 value is 9 minus U1 and V3. V3 is minus 8. U1 is 6 minus 8 is minus 2. Value is 11. After D13, I have D14. D14 equal to 3 minus U1 and V4. U1 is 6, V4 is minus 3, 6 minus 3 is 3, 3 minus 3, 0. Then the next is D21. My D21 is 11 minus U2 and V1. So it is 11 minus 10, value is 1. After our D21, we have D24. Our D24 is going to be 8 minus U2 and V4. U2 is 10, V4 is minus 3, 8 minus 7, value is 1. After D24, which is the next unoccupied cell, I think it is D32. So I come for D32. What is the value of D32? D32 is 12 minus U3 plus V2. U3 is 10, V2 is minus 5. So 12 minus 5, value is 7. After our D32, come for D42. So I will have D42 will be 0 minus U4 and V2. The value is plus 5, which is greater than 0. Then we have D43. D43 is again 0 minus U4 D3. U4 is 0. D3 is minus the values? All my Dij is greater than equal to 0. It's not greater than, it's greater than equal to 0. Therefore, alternate solution exists. Alternate solution exists, but we have obtained an optimum solution. Okay, alternate solution exists, but we have obtained an optimum solution. So what is the optimum allocation schedule for the problem? Therefore, the optimum allocation schedule, the optimum allocation schedule will be, what is the schedule that we got? We got x11, I think value is 40. Then we have x12 30. Then what else did we have? X22. We had x22. The value is 5. Then we have x23. We have x23 and the value for that is 50. Then x31 value is 25. x34 the value is 45 and the value for x41 is 20. Now having got the allocations, we can find the optimum or minimum transportation cost. Therefore, the optimum or minimum transportation cost, the optimum or minimum transportation cost will be equal to, just keep multiplying the cost with the cell entry. You will have 6 into 40 plus 1 into 30. So 6 into 40 is 240 plus 1 into 30 is 30 plus 5 into 5 25 plus 2 into 15, I think value is 100 plus 10 into 25, I have 250 plus 7 into 45, 7 5s are 35, 5 carry over 3, 315 plus 0 into 20. Plus 0 into 20 will give me only 0. It's not going to add on to anything. So now what happens? We have a 40 plus 30, 70, 95, 100, 110, 160. Then with this 160, 260, 460, 660 and 300. So 960. So the total is rupees 960. So this is the required optimum minimum transportation cost. Okay, so this is a problem which is very useful for us. It is doing unbalanced problem. We have balanced it. We have applied VAM. Having applied VAM, we got the basic solution. And then after getting the basic solution, we found out using Modi method, we wanted to move for optimal solution. When we moved for optimal solution, we got a Dij to be negative. So since the Dij was negative, what we had to do is we had to still further work on it. So we formed a loop with the position where it was negative, added a huge cos plus theta, a huge cell allocation. So in alternate points of the cell loop formed with the plus theta, it will go as positive, negative alternatively. Choose the minimum value of all the negative values available in the loop. So it is minimum of 65, 30 and 25, which is 25. So correspondingly, add 25 if it's a plus theta, subtract 25 from the allocation if it's a minus theta. We get the new table formed here. After we get the new table formed here, once again we repeat the process. What process we have done? Modi method. We calculate Cij for occupied cells. We calculate Dij for unoccupied cells. Our only constraint here is this B14, which is 0, which tells us the existence of an alternative optimal solution since all other Dij are greater than equal to 0. So finally, we are giving you the optimum allocation schedule and the optimum minimum transportation cost. So with this particular problem, we have imbibed almost all possible cases except degeneracy. Okay, so this is a fulfilled example I hope it's going to be useful for us.